All right, here to do a quick tutorial on the Fluent 2D simulation of an airflow over a flat plate. So go ahead and create the geometry. All right, so right here, go into the YX plane, go to sketching. We'll create a small little rectangle right here. All right, now you want to get dimensions. Okay. All right. Now, so for this plate, we are going to do the length of 100 centimeters, which is just 1 meter, and the height we want to be half that. That way we can have enough space for the meshing, uh, or more particularly, enough space for cells at the bottom to simulate boundary conditions. We need a lot of space for that, a lot of cells for that. So now we go to surface some sketches. We can select all the lines. Apply, generate. There we go. Now we have our sketch. So we can go ahead and exit out of this. Now we can start meshing it. Okay. All right. And we can generate the first pre-mesh. This will just be a bunch of squares, which is not good enough for our case. So since we want there to be a lot of cells down the bottom, we're going to do a couple little tricks to get there. First thing we're going to do is we're going to put a face mesh, select the whole thing, apply that. And then next thing is we're going to do a couple of sizing techniques. So the first size we're going to do top and the bottom for the geometry. So we got two sides. We'll do number of divisions, and we will set this to, let's do, for the sake of the video, let's do 50. That way it's quick and easy. And I'm going to go here to curvature, no, behavior to hard. Nice. All right. And then we're going to do this again, but a little differently this time. I'm going to do just the front, apply that, number of divisions, do 60. And now we want to compress all of these divisions right here down to the bottom. So in order to do that, going to do the same thing as before. We're going to do behavior. Okay. And then we're going to do a bias, which is the first option there. And then we're going to do a bias factor of 70. That way, this squishes all of the divisions down towards the bottom of the plate right here. And that is good to go. And now we need to do the same for the outlets. So we'll do this side right here, apply it, same as before, number of divisions. We'll do 60, capture curvature off, set this hard, and then I'm gonna do a bias and the same thing as before. Except for this side, it's flipped, so it's the bias towards the top. So we're gonna do a reverse bias, where we just select the line and then click apply, and then it matches the front. So great. Now that we are ready to go, we can generate this. And we have a much better mesh to work with. A lot more cells towards the bottom, which is exactly what we want. Now that's done, we could start naming these sections. So we'll just click the entire face, click N, the shortcut to name it. We'll call this just the airflow because this is just the area where the air flows. And now we'll name each individual line. Let's do this one just top. Inlet. And this one is the plate. and the outlet. Okay, and great. Now we have all five. We are good to go with the meshing. So we can close out of this. And we can update this. All right. And now we can start the setup, which is just the actual simulation part. All right. Okay. And now that we are in the Fluent, now we can start setting up some conditions. So f for this condition, or sorry, for this simulation, we are going to set the density to just 1.2 and the viscosity just 1.8 power of negative 5, or 1.8 times 10 to the power of negative 5. And then for the materials, we're going to do fluid. We're just going to modify the air. Do the same thing here, 1.2 and 1.8 times 10 to the power of negative 8. Okay, got that. And we're going to do just a low velocity. So go to the inlet velocity, and we'll change this to um, 2 meters per second. And that's pretty much it. Just quick and easy. We'll just double check these values. Yep, yeah, the velocity is at 2. Okay, now that we got that, we can start initializing it. Very simple simulation, so it shouldn't take long at all. Now we can run the calculation. We'll do 200 iterations and then go through it. All right. And there we go. Now we got that. We can start going over the results. We're not going to go over too much in this video since it's just a quick one, but we'll go over the vectors and we can display all of these, compute on display, and you can clearly see the boundary layer right here. It starts off at 0, no slip condition, and quickly goes up. And this changes obviously as you move along the plate. Cool. Now we got that. There's a couple other things we can do. Um, we can go to plots, XY plot, and we can start exporting some data to an Excel or just look at. So we can do a y-axis function of pressure or velocity. We do wall fluxes, wall shear stress, or skin friction coefficient on all these areas. Could plot that. And there we go. And yeah, that's pretty much it. Thanks.